I wanted to see what it would be like to build a note-taking app using only Rust frameworks and components across the entire stack, including the database, front-end, and back-end. We're going to build this simple browser-based note-taking application, kind of an analog to something like InkDrop or Apple Notes. You know, something that'll help us remember to do important things. Okay, so this is our note-taking app. When we first load the page, we get this nice little loading spinner. Once everything's loaded, we get a list of notebooks that we can select. Once we've selected a notebook, we can kind of browse through the notes in that notebook, and we can create a new note using this button here. We'll go to the new note, set the title, and then we can edit the content here. Click the save button, and our changes are saved. We can go ahead and delete that note using this delete button, and we can go into an existing note and edit that note. We can select all notes, and that'll show us every note across all the notebooks. And then of course we can add a new notebook by using this plus button right here, new notebook. And then we can start adding notes to our new notebook. Look, let's be real. This is not going to be a competitor to Obsidian or anything like that, but from a developer perspective, it'll surface a lot of the patterns that you'd see in a consumer-facing app. All this is running in the user's web browser, so we need something that's going to be handling the user clicking on stuff, creating new notes and notebooks and so on. For that, I'm going to want a reactive front-end framework like React.js or one of the 1,000 other frameworks that were inspired by it. Then, of course, we're going to need some back-end APIs. We need an API to load the list of notebooks on the left, and then an API that, given a notebook, loads a list of note summaries in that notebook, an API to load a note, and then create, update, and delete APIs for both notes and notebooks. I think that covers everything. And then the backend needs to store all this stuff somewhere. I'm not an expert, but I think that's called a database. I'm a little rusty at this, but luckily in this video, we're focused on rusty choices. This video is kindly sponsored by warp.dev, so thank you to them for supporting the channel. This video isn't about Warp specifically, but I've been using Warp for the past few months, and there are definitely some features I found pretty valuable, so I'll show those off as we go. Okay, so we want to choose a database that's written in Rust. This is a silver platter of some pretty interesting options, and SurrealDB is definitely one of the most well-known. It aims to give developers the flexibility of SQL and graph databases with the scalability of key value stores like Redis and DynamoDB. The access patterns of what we're trying to build are well within the realm of what SurrealDB is capable of. Neon is another interesting Rust storage solution. It would probably work for what we're trying to build, but it's actually not a full database solution. It's more of a storage layer that allows Postgres to scale more easily, which means that it's not really entirely in Rust, so I decided that it doesn't quite fit the criteria of the video. Then there's something called TiKV, and TiKV is a key value store that aims to provide automatic data migration when database nodes are added and removed. To me, it sounds like it's aiming to offer a lot of the benefits of AWS DynamoDB, but in an open source project entirely written in Rust. That sounds pretty compelling. Then there's Melee Search. Excuse me, it's actually called Melee Search. You might have heard of Elasticsearch, which is a popular way to get full text search in a way that's ultra scalable. Melee Search seems kind of like a Rust equivalent of Elasticsearch, but it's not really intended to be a durable data store, meaning it's expected that your primary data store is somewhere else, as you could lose the entire contents of your Melee Search store at any time. That said, it's not my intention to productionize this project, so for the purposes of this video, that's not necessarily a deal breaker. There is a vector database written in Rust called Quadrant, and vector databases are useful for what's called semantic search, which we're not going to be doing for this project, so we'll go ahead and rule that out. Semantic search is a search where the results are based on the meaning of the search terms, not necessarily the exact matches of the search terms. If we were to take this thing further, semantic search actually might be a nice feature, but yeah, outside the scope of this video. Okay, after all that, I decided on SurrealDB. You could make the case that it's kind of the golden child when it comes to databases built in Rust. It has some pretty compelling narratives around both query flexibility and horizontal scalability, because usually you have to choose one or the other. You usually don't get both at the same time. There are definitely some open questions around its performance, and at the time this video is being made, it's not officially production ready, but we can afford to go bleeding edge on this project. Plus, SurrealDB has significant investor backing, so we can be relatively confident about its future. There's also a pretty nice graphical interface for poking around in your tables and manually executing queries. We'll look at that more toward the end of the video. Now we have to choose a framework for running our HTTP server that's going to expose our backend APIs and serve up our static files that contain the front end. There are quite a few options here, and some of the most popular ones are Rocket, Poem, Axum, and ActixWeb. And then we have some choices for our front end framework, and those include Vue, Leptos, Dioxus, Sycamore, and many others. Leptos and Dioxus also happen to be full stack frameworks, so they can come with a backend built in. Lately, I found it increasingly hard to justify not using a full stack framework, so for this project, we're going to go with Dioxus. Now, most people probably wouldn't normally consider their terminal emulator part of their tech stack, but Warp is a fully Rust-based terminal, so in this video, I'm including it as part of the stack. Warp is the only terminal application I know of that forces you to create an account and log in before you can use it. Look, I don't want to have to log into my terminal application. By the way, thank you again to Warp for sponsoring this video. But let me break this down as simple as I can. I don't want to have to log into my kitchen refrigerator either. That would be terrible. But if this refrigerator automatically shops for groceries and does all the cooking for me, I'll memorize a 100-character password if you want me to. I'll wake up in the middle of the night to re-enter my credentials. Once you become spoiled with some of the features of Warp, you start to find it hard to go without those features, and we'll cover some of those features throughout this video. Look, nobody really wants to log into their terminal, and the Warp developers realize that. But it opens the door to some really nice features that you wouldn't be able to have without logging in. We'll get to some of those. Okay, to walk through how this thing is built, we're going to start with the back end and sort of work our way to the front end. One interesting thing about SurrealDB is that it's really flexible in terms of where your data actually gets stored. To start SurrealDB using an in-memory storage layer, which means all of your data is going to be completely wiped when you restart SurrealDB, you can do surreal start memory, and you get SurrealDB running using an in-memory storage layer. If you want to use a file as a storage layer, you can do surreal start and then file : and then some name .db. So now my data is going to be durable and it's going to be persisted to this .db file. Obviously, if you're running in production, you're probably not going to use a file as your storage layer. You can use a TiKV cluster as your storage layer. So to do that, you do surreal start and then TiKV and then IP import. That's outside the scope of this video. And then if you want to put your data on the blockchain, you can do surreal start and then blockchain. I'm just kidding, you can't do that. You can't put your data on the blockchain. For now, we're just going to do surreal start and then we're going to store our data in a file. So we'll do notes.db. Okay, so how do we run this thing? Well, Dioxus actually has a dedicated command line tool that you can install with cargo install Dioxus CLI. To actually run our web application and get hot reloading, we have to execute this long verbose command. So we'll do dx build, and you can see Warp actually auto-completes based on my command history. So that's really nice. So I just do right arrow to fill out the rest of the command and then enter. And I'm running the command that came from my history. The other cool thing about Warp is that the command that you ran actually kind of floats at the top. And this is configurable, but by default, if you didn't want this, you could actually disable it and have it work like a traditional terminal. But by default, the command that you run actually floats kind of on top here. So regardless of how long the output of the command is, you still see what command you ran. I find that kind of useful. And I'm hard pressed to think of a scenario where you wouldn't want that. It's my personal preference to have this. And then this is what's called a block, the combination of the command that you ran and the output. So I can cycle between blocks by doing command and the arrow keys. And each time I go to a different block, it shows me both the command that was run and the output. Again, irrespective of how long that output was. So in a traditional terminal emulator, you might be kind of wading through tons of output to find the commands that you actually ran that were associated with that output. So this is really nice for easily searching through your command history and correlating which output came from which command. The other thing I want to point out, because it's really important to me, is that Warp supports Vim motions at the command line. So I can do escape, BBB to go back, GW to delete a word, U to undo, $sign to go to the end of the line, capital A to go into insert mode at the end of the line, so on and so forth. This is not unique to Warp. You can do this in other terminal emulators, but I wanted to emphasize that Warp does support this because for me it's important and probably some other folks too. All right, before we start implementing our server functions, we do need to establish some models. And here we have our note model. It's got 4 fields: ID, title, content, and notebook. ID is actually an option because when we're first creating a note, we don't want to generate an ID. We want to allow SurrealDB to do that for us. So on note creation, we actually pass in none for ID. And then subsequently, when we retrieve notes, that ID should be populated by SurrealDB. Title and content are pretty self-explanatory. And then notebook is the ID of the notebook that this note is associated with. Notebook is pretty similar. Again, it has an ID that's an option of a string, and then it has a name, and then it has a field called count. And count is an option of an unsigned integer. And that's what we're going to use to represent this number of notes that is displayed next to the notebook name. Obviously, when we're creating a notebook, we're not passing a count to the server. That field is only going to be used when we're calling get notebooks and getting a list of the notebooks and the associated note counts for each of those notebooks. So that's why it's an option, because it's going to be none every time we submit a notebook to the backend. Now that we have our model set up, let's look at the server functions. Okay, the best feature of REST full stack frameworks, in my opinion, is server functions. And I've talked about these a lot in previous videos, but long story short, this is where we're going to actually make our queries to the SurrealDB instance. For retrieving data, we have get notebooks, get note summaries, and get note. And then for inserting and updating data, we have upsert note and upsert notebook. And then of course for deleting, we have delete note and delete notebook. Now let's go ahead and add the implementations. Now that we have our implementations, let's try running this. We got an error. Use of undeclared crate or module SurrealDB. Cool feature of Warp, we can select a block that we got an error on. So we'll select this block here, and then we can do Control-Shift-Space, and we get this AI prompt with the output of that command pre-populated, and then how do I fix this? And I can just press enter, and it's gonna give me a response. To fix the issue mentioned in the output, you can follow these steps. I have some warnings here that it's addressing, but for number 3, you can see the error message failed to resolve undeclared crate or module SurrealDB indicates the compiler cannot find the SurrealDB crate. This is a little contrived. It's from the error message, it's pretty obvious what the problem is, but you can see the value here. You can definitely get a lot of cryptic error messages when developing, especially in Rust and using Rust full stack frameworks. So this is super handy to have. Let's talk a little bit about how we're gonna add this SurrealDB dependency. A little background here is that with full stack frameworks like Leptos and Dioxus, there are different features enabled depending on whether we're building for the client side or the server side. Taking a look at cargo.toml, we can see we have a feature called SSR, and that enables all the features that we specify here in these square brackets. So we can enable and disable optional dependencies. So when you add a dependency to a project, you'll need to think about whether you want it on the client side, server side, or both. If you need it in both places, you can just add it with cargo add. So I could do cargo add SurrealDB. But we can't do that because we can't have the SurrealDB dependency on the front end. So what we need to do is add it to the list of dependencies as optional, similar to how async once is. And then we also need to add it as a feature to our SSR feature. So we need to put it in this list of features inside these square brackets. This is something that's ripe for automation, and I'm not 100% sure yet, but I think this might be my favorite feature of Warp. I can actually make what's called a workflow. To create a workflow, I can do Command-Shift-H, and I can give it a name and a description, and then I can enter the command that I want. In this case, I'm gonna do this crazy command. It's cargo add and then crate name. So I have an argument called crate name, and I put that in 2 places in my command. First, this is gonna run cargo add, and then add the crate name, which again is an argument. If that succeeds, it's gonna call sed. Outside the scope of this video, what sed is, but basically it's going to insert that feature in that list of SSR features that we saw. I could give this a name. I could do like add SSR or something like that, and then I could give it a description. But check this out. I can have the AI autofill the name and description. So I just click this autofill button, boom. Add an optional dependency to a Rust project and update cargo.toml. The AI is interpreting what it is and giving us a title and description automatically. That's pretty cool. So I'm gonna do save workflow. So now to run that workflow we just created, we can do Command P and then search for it, add optional dependency. It's gonna walk me through the arguments that the workflow requires. So we can see crate name here. I can just do SurrealDB, press enter, and it's added the dependency and ideally added it to that list of features as well. Let's see if that happened. Yep, there it is. So we have it here as an optional dependency, and then we have it in this list of features associated with the SSR feature. Cool, that's workflows. Now that we have our dependencies set up, let's implement those server functions. The first thing we need to do is set up a connection to the database, and we need to have this connection shareable across all of our server functions so we don't have to reset it up every time a server function is called. We can do this using lazy static, which allows us to create a static variable that gets initialized the first time that it's referenced. This code won't be run immediately when the program starts. It's going to be run the first time this DB variable is accessed. The SurrealDB setup functions are async. So to set up this static variable, we need to use async once, and then we pass it the async logic that needs to be run. We create a new Surreal connection, call await on that, and then panic if it doesn't work. And then we specify a namespace and DB to use. So all in all, this gives us the ability to reference this DB variable in our server functions and perform whatever database operations that function needs to perform. Let's take a look at upsert note. Upsert note takes a note as a parameter. First, it's gonna get the connection from that DB variable that we looked at earlier. If the ID field is some, that means we're doing an update. And if it's none, that means we're creating a new note. So that's what these two if-else branches represent. In both cases, we need to bind the values of the note that got passed in to tokens in the query string. And we do that using the bind function and passing in a tuple. The first element of the tuple is the token that we use to represent that value in the query string. And the second value of the tuple is the value from our note structure. And then in the query string to reference one of these tokens, we just prefix it with a $sign. So we can see we're binding notebook to note.notebook. And then in the query string, we have $sign notebook right here. And we are casting it to a thing. Thing in SurrealDB terms is like an ID of something. In our note object, it's a string or an option of a string. So we need to cast that to a thing. And then of course we set the title and content fields to whatever was in the note that got passed into the function. The create branch is pretty similar, but there's no ID to worry about because we don't have an ID yet. We just create the note. On the back end, SurrealDB assigns an ID to it. And then next time that note is retrieved, that ID field will be populated. GetNote is pretty similar. It takes a note ID as a parameter. In the query string, we do need to cast that note ID to a thing because that's what Surreal expects. So you can see that here. And also notice that we don't specify a table. We just specify an ID because in Surreal, the table is built into the ID of the record. The ID of a note will be note : and then the random identifier. So that's kind of handy. And then because we're deserializing this into a note, we do need to cast the ID in the notebook to a string because the note struct has strings, not things. Once you understand those two server functions, the rest are very, very similar. Those two cover most of the concepts. The main function is where everything kind of starts from, and there's not a whole lot here. We're just calling this launch builder new function and passing in the app function to it. Launch builder new is part of the Dioxus framework. The app function is actually where our application logic resides. It takes a scope as a parameter and returns an element. All Dioxus components kind of follow this pattern. An app is just basically a top level component that holds all other components. In the beginning of the app function, we set up all the state that we're going to have to keep track of. And there are 4 main things. Once you understand these 12 lines, you'll pretty much understand how the front end works. First, we always need to maintain a list of notebooks. And then 2, if the user has selected a notebook, we need to maintain a list of note summaries for that notebook. 3, we need to track which notebook the user has selected, if any. And then 4, we need to track which note the user has selected, and that's going to dictate which note actually gets displayed in the main pane. If you've ever used React.js, you're probably familiar with useState. In Dioxus, the concept is pretty much the same. It allows you to set up some state that will be automatically re-rendered on the page whenever it gets changed. We have 2 pieces of state that we want to track that don't come from the server. One is the currently selected notebook, and the other is the currently selected note. We need to know both because we want to visually highlight the selected notebook and load the note summaries from that notebook. And then obviously we need to know the selected note because that dictates what note gets loaded and displayed on the main pane on the right. For the other 2 pieces of state that we need to maintain, the list of notebooks and note summaries, some data needs to be retrieved from the back end. And for this sort of state where some async operation needs to be executed to get the initial value, the useFuture construct is a good fit. The third parameter of useFuture is a closure that performs the async operation that you want to use to populate the state. In the case of notebooks, that's just the getNotebook server function that we wrote earlier, which is pretty nice. Note summaries is a little bit more involved. The second parameter of useFuture is a tuple of states that the future is dependent on. If a dependent value changes, the async operation that populates the future needs to be rerun. So by specifying the selected notebook as a dependency of the note summaries future, Dioxus knows to reload the note summaries whenever the user changes the selected notebook. We use the state of the notebook's future to kind of determine what to render. In the case where the future is completed, we'll render that notebook bar because we probably retrieved that list of notebooks from the server. And then if they've actually selected a notebook, we're going to render the column of notes contained in that notebook. And we're also going to render the note view, which is where the note is displayed when they click on that. If the user has selected a note, we'll show that note in the note view pane here. If the future is still pending, we're going to just display a loading spinner basically. We do want to make sure if the user selects a different notebook, we want to reset that main note pane, because if they have this note selected and then they select a notebook that note is not in, it wouldn't make sense to display a note that's not in the notebook that they've selected. That's what this use effect here is for. So what this means is whenever selected notebook changes, we want to call .set to none on selected note. That's all it is. Those are the sorts of things that useEffect comes in handy for. All right, let's take a look at the notebook bar component. You probably saw we reference other Dioxus components in this render macro, notebook bar, notes bar, and notes view. Let's check out notebook bar. Dioxus components are all annotated with this component macro. Other than that, they're just normal Rust functions. They take a scope as the first parameter, and then for subsequent parameters, they can take whatever you'd like to pass in from the parent component. So in this case, in the case of notebook bar, that's the notebook's future. and the selected notebook, both crucial for notebook bar to have access to. What we're going to show in the template is going to depend on the list of notebooks. Of course, we only want to render the list of notebooks if we receive the list back from the server, which is what is tracked by the notebooks use future that we saw earlier. And if the value of the future is an OK result of a vector of notebook wrapped inside a sum option, that means we're clear to render the list of notebooks. Otherwise, something went wrong, which is handled by this other match arm down here. We can put a for loop directly inside this div element, which is really nice. So inside, we can iterate over the list of notebooks and create a div for each notebook, and then have various things inside that notebook, including an onClick attribute, which calls selected notebook.set on that particular notebook. So you can see that here. So each run of this for loop essentially represents a row in that notebooks bar column. So work is an iteration of the for loop, Rust is an iteration of the for loop, and each one of these is a div, and in that div you have the name of the notebook and then the counter. The counter is just a tiny component that displays that number that you saw, indicating the number of notes in that notebook. This block right here represents the element that needs to be displayed after the user clicks the Create Notebook button. So if I click this plus here, we see this input field. That's that element. So that's only rendered if we're in a creating notebook state. We can see we have an onKeyDown attribute on that input element. If the user hits enter, it's going to call this submit notebook function. And if you look at this submit notebook, there's a lot going on here, but you can see these two own functions. Without going into too much detail, it took me a long time to realize that I needed these two own functions here. So to show you the error that I was getting, let me delete these and see what the build says. CX is a reference that is only valid in the function body. Not the most helpful error message. So say I want to get help on the Dioxus Discord server to try to figure out what's going on here. Warp has a really nice feature called shared blocks. Instead of copying and pasting all this output and the command and everything and pasting it into Discord, I can just do share block or share selected block, create link, and then I get this nice link that I can paste into the Discord server, and they get everything that I saw. They get the command that I ran, all the output, including the original syntax highlighting. This would be even more useful if the output that you had to share was just really massive and it wasn't realistic to paste into a Discord chat. SurrealDB also has a pretty good web interface. I'm pretty sure it's not created by SurrealDB themselves. I think it's created by a third party. Anyway, so we can browse through the tables, click on records, or we can perform arbitrary queries. So this is kind of handy. By the way, if you're into themes, check out all these themes that Warp has. I personally like the default one, which is called Cyberwave. It's got this nice gradient, black to blue. But yeah, there's something for everyone here. Fancy Dracula, nice. All right, that is the draws stack and a deep dive into some of the areas of the code. Overall, I'm pretty happy with how it turned out. Of course, Dioxus is still in a pre-1.0 state, and SurrealDB does currently have some questions around production readiness. But once these projects gain a bit of maturity, this is a stack I could definitely see myself building business-critical applications with. If I were to productionize this, I think the next thing I'd look into is integrating SurrealDB with a TiKV cluster. I'm guessing maybe that's a topic for a whole video. Let me know if that's something you'd want to see. Thank you again to Warp for supporting the channel. Definitely check it out if you want your refrigerator to do your shopping and cooking for you. I mean, if you want to have a more modern terminal that can make you more productive. Let me know in the comments what you think of this tech stack. Do you like it as is? Would you swap out some of the layers with other things, or would you use something else entirely? Let me know. If you are interested in full stack Rust frameworks, definitely check out this video where I use the Leptos framework to build a ChatGPT clone. Thanks for watching, and we'll see you in the next one.